So this is the first video for week 2 of Science 30. And this video is about why different stars or things in the sky appear as different colors. Now this would be through some different types of microscopes, maybe not necessarily just a normal telescope. If you were to take kind of the one in your backyard and look up at the stars, a lot of them would just be kind of like bright white stars. But if you were to have a better telescope or a better way to detect some of these different stars, you would see some of these different colors. So this question is, why does the Horsehead Nebula in Orion appear red? Now, we are going to kind of look at why this redness might be in terms of two different things. The first is the elements that are present. Every element has its own atomic structure where we have the nucleus here at the center, and then we have these different energy levels with different amounts of electrons in each. Because all these elements have different structures, we can end up with these different what are called emission lines when these electrons change energy levels. As those electrons fall back down, they actually end up emitting different wavelengths of light, and we get these different bands. Now this is because they have electrons at different energy levels. And every element has its own unique fingerprint. So these are different emission lines for all of the different elements. You'll see that some of these smaller ones are relatively simple, like hydrogen and helium, because they're relatively small atoms. But we have a whole wide variety of different emission lines. And you'll notice that no two elements are the same when it comes to the emissions that they actually give off. And so we can use these to actually identify the elements that are present. These are emission spectrums. So we would take this gas, we would excite it, and then these are. So when we look at some of these stars and some of the spectrum that are coming off of them, one of the reasons why one star might be more red than another is the presence of different elements in it. So depending on the relative abundance of different elements, we'll get more of specific wavelengths compared to some other wavelengths. Now, when we view those, so all these previous examples that we would see, there's really three types of spectrums that we can see. The first is a continuous spectrum, and this is what we get whenever we just heat up an object. So if we were to take a light bulb filament and heat it up, and you were to look at that light bulb, you would get a continuous spectrum. If you were to be very close to the sun and look at the sun, you would get a continuous spectrum. This continuous spectrum is kind of like what we were talking about with EMR. It goes in the order of Roy G. Biv. We get all these different colors that are showing up in that spectrum. Now, if we take a continuous spectrum, so this is emitting a continuous spectrum. If we take this continuous spectrum, we can get some different types of spectrums from this. The one that comes from a continuous spectrum is this absorption line spectrum. This is if we actually had a very good way to view the emission spectrum from the sun, or the spectrum that's emitted from the sun. This is the type of spectrum that we would see because the sun actually has its own atmosphere, and so does the Earth. So as light travels through the atmosphere of the Earth and the atmosphere of the sun, we actually end up getting specific wavelengths that are left out. So this is any time we have something that emits a continuous spectrum, that light passes through a cool gas. Now this is a relative term. The atmosphere of the sun is still very, very hot, but it passes through that cool gas, and we end up with these bands that are missing. That's an absorption spectrum. Now that's different. If we were to take a gas and then actually heat it up, we would get this emission line spectrum. And this is if you look at a lot of like mercury vapor lamps, or if you have like a halogen light bulb at home, these are filled with gases that are excited. So we put electricity through them, and then they emit a whole bunch of different wavelengths of light. Now our eye just detects that as just white light. Or maybe it's like a neon sign. We see it as an orange sign. But all of those different wavelengths are there. And if we were to separate it out using like a diffraction grating, we would see those different bands. So these are the different type of spectrums that we can see. It doesn't change between elements, between an emission spectrum and an absorption spectrum. The only difference is an absorption spectrum, we're missing those bands. In an emission spectrum, we only have those bands. So the other reason why stars can appear more red or more blue is because of the Doppler effect. And this is something you might have seen before when you see cars with sirens coming down the road, or even just a really loud exhaust. You hear, you'll hear it get higher and higher in frequency as it comes towards you, and then as it drives away, or as it passes you, that frequency drops off right away. That's what's called the Doppler effect. And that leads sometimes to being able to view these different stars as being more red or more blue. We say that something is red shifted if it's moving away from us, because as it moves away from us, the light that's traveling towards us actually appears to be stretched out and is shifted towards the longer wavelengths, which is the red wavelength in the visible spectrum. If something is coming towards us, it's said to be blue shifted because that wavelength seems to be closer together because it's traveling towards us. And that is because of the Doppler effect. So we have red shifted or blue shifted based off of whether something is traveling towards or away from us. And that's another reason why things can appear more red or maybe more blue. It tells us the direction they're traveling. So when it comes to why does the Horsehead Nebulae appear more red, it could be a couple of different reasons. The first is that there are more of these types of elements present. So there's a relative high abundance of hydrogen and helium. And so we get these very red emissions coming off of it. The other reason could be that it's moving away from us. And so these emissions that we're getting are shifted towards the more red part of the spectrum because of the Doppler effect and because it is moving away.